Here's a review and a help video for solving radical equations. What we're going to do is do two kind of basic ones first, and then we'll make our way to more difficult problems. The first one here says the fifth root of 4x minus 8 equals 2. We can't access anything under the radical here unless we undo the operation that's currently happening to it. And the operation is that 4x minus 8, the fifth root is being taken of it. So in order for me to cancel that out, I need to raise each side to the fifth. The root and the power cancel out, so we'll have 4x minus 8 equals 2 to the fifth, 32. We'll have 4x, and then if we add this 8 over is 40. So x is just equal to 10. And then if we go ahead and do a check, this will make sure that we know if we've gotten it right or not. So we'll have the fifth root, 4 times 10 minus 8 equals 2. And we're checking to see if this equals 2. So I'm just working on this side. So the fifth root of 40 minus 8. So the fifth root of 32 equals 2. 2 equals 2. So that's all set. And we can go ahead and circle our answer because we know it's right. All right, the next problem, we have a radical with the variable underneath it, but I have a bunch of other things happening. So I have to go ahead and straighten that out first. So I'm going to use the SADMEP, which means we're going to subtract, add first. So I'm looking to the side with the radical. This 5 is being subtracted, so I'll add 5 to the other side. Let me actually do that so you can see that. So plus 5 plus 5. And now I have this 2. And you have to remember, anytime you have a number right outside a radical, it's being multiplied. So we need to divide. And we don't divide it into anything else, just that number out front. So I'll have 6 equals the square root of 3x plus 12. And now to get this radical away, I need to raise each side to the second power. And by doing so, I'll get 36 equals 3x plus 12. We'll subtract 12. So 24 equals 3x, and x equals 8. Now let's make a check and see if it works. So for our check, we'll have 7 equals 2 times the square root of 3 times 8 plus 12 minus 5. We don't know if it's equal. So 7 equals 2 times 8 times 3. We get 24 plus 12 minus 5. 7 equals 2. Square root of 36 minus 5. 7, so I'm not moving anything to do with the 7. 2 times 6 minus 5, so 7 equals 12 minus 5, so 7 equals 7. Yay! And then we go ahead and circle our final answer. Here we have in this next problem, x plus 75, all raised to the 3/2 power, equals 1,000. And this really is a radical, right? That this right here, if we kind of make a side note, is that x plus 75, well, the denominator is our radical in the index, and this is the power. So I really do have a power over here. A radical that's trapping this x plus 75. And I could go ahead and divide by 3 or raise it each to the 1/3 power, but that takes too many steps. So what we're going to do is right away, let's take this power and raise it to the reciprocal. So really think about raising it to the reciprocal. When you do that, then these fractions cancel. So don't think of multiplying each side by 2/3. You are multiplying the exponents. So you can think about multiplying the exponents. When we do that, we have x plus 75 equals, well, 1,000 to the 2/3 really means the third root of 1,000 squared. And we're going to have the third root of 1,000, that's 10. 10 squared is 100. And so x would be equal to 25. And let's do the check. So when I check, I'm going to say, okay, is x plus 75 raised to the 3/2 equal to 1,000? Oh, let's put in the actual value there. 25. All right, well, we have 100 to the 3/2 equals 1,000. We're not sure. So 100 to the 3/2 means the square root of 100. Well, that's 10. And 10 raised to the third is 1,000. So that one works.